In Chapter 6, we're going to be talking about solving systems of equations. You're going to learn about 3 different ways to solve systems of equations. And the first one we're going to look at today is graphing. Then you'll be looking at something called substitution and something called elimination. So today is the least efficient way of solving these, but it's a good visual for you to see what you're looking for when you're solving them. And once we go through today's lesson, you won't be using graphing on a regular basis. You'll be using the other 2 more often, but it's good to at least see it this way. So go ahead and write this example down and hit play when you're ready to start again. You're going to be using everything that you learned about graphing linear equations with solving these systems today. So what you're going to end up doing is graphing this line and this line on the same plane. It's basically Chapter 5, but 2 different lines on the same plane. So let's go ahead and do that. Let's graph the first one. I'm going to graph it as a pink line so you can see the difference between the 2. Hopefully you notice this is in slope-intercept form. If you want to hit pause and graph it on your own for practice, you can, and then hit play to make sure you did it correctly. So your m is 2 over 1, and your b is -3. You're going to start at -3, up to right 1, up to right 1, up to right 1, up to right 1, up to right 1. Go ahead, connect all of your points so you have a line. And then let's look at the next one. We'll look at the next one in green. Same thing, this one happens to be in slope-intercept form, so we can use the same thing. Our slope is 1 over 1, and our y-intercept is -1. So you're going to graph this line on the same plane. So we start at -1 on the y-axis, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. Go ahead and connect those lines, or those points. Now take a look at this graph and think about what you notice about it. What most of you probably noticed is that there is a point right here where both lines cross. What this means is that for this pink line, every point along this line is a solution. For this green line, every point along here is a solution. And there is one point that matches, and it's a solution for both lines. That is your answer to a system of equations. And we talked about this earlier this year in Chapter 2 when we were talking about when is the cost the same. And I drew you the picture and I showed where they crossed, and that was when the cost was the same. That's what all of these graphs that you're making today, you're going to be looking for, and that's what you're basically solving for every time you solve a system of equations. You're solving for that one point where it would have been a solution for both lines, and it's where they cross. So for this, you would actually write the solution is 2, 1, because they cross at the point 2, 1. Now you can check that, and you check it by plugging it into the 2 equations. So I'm going to check it by plugging it into the first equation, 2x subtracting 3. Remember, I'm plugging in this for x, this for y. I'm going to see if it balances. So we'll go ahead and check it. 1 equals 2 times 2 subtracting 3. So this is the x and the y there. And now we'll see what we get. And it should balance. 1 equals 4 subtracting 3. 1 equals 1. It balances. So it is a solution for the first equation. But now you need to make sure that it's also a solution for the second equation, for the second line. If it's not a solution for both, it's not a solution for the system. If it's a solution for one and not the other, it means it's one of these points along here, or up here. It has to be true for both of them to actually be the point where they cross. So now we'll check it in the other equation. Y equals x subtracting 1. And you are going to have some homework that asks, is this solution a system, or is this a solution? And you plug it into both equations to check it. So we end up with 1 equals 2 subtracting 1, and 1 equals 1, so it is a solution, and that's how you check. Now, I want you to understand that part of the reason that graphing isn't the easiest way to solve these is because we got lucky on this one that it crossed at a nice easy point to find, 2, 1. But what if it crossed like right there in the middle there? You don't know exactly what it is because it's going to be some type of fraction or decimal if you want to look at it that way. And so you're going to have to estimate those. You're going to have to do the best job estimating those. And as long as you're close, then I would consider that correct, because not every single one is going to cross perfectly like that. So you always want to estimate the best you can. The other thing you have to be really careful of, you need to make sure that you're drawing your points as neatly as possible. Use graph paper, and connecting your lines as straight as possible. That's going to give you the best point where they cross. Otherwise, yours might be off a little bit. We're going to add some stuff to the left. Just go ahead and hit pause once I'm done talking about this. Finish copying down this part, and then hit play again, and then I'll move this up so you can see the other part. This is basically talking about what I said in the example. The solution to a system is the ordered pair that makes all equations true, what I talked about when we checked our answer at the bottom, or the point where the lines intersect. It's both things. This point is what makes these equations both true if we were to look for them and balance them out. So go ahead and hit pause, hit play when you're ready to look at the other part. Solve by graphing. You're going to graph each line on one coordinate plane, and then you find the point where they intersect, and that's your solution. And then you check it by plugging that solution in to make sure that they both balance out and are true. Go ahead and copy this down. Hit play once you're ready to go over it, but we're going to start word problems. Remember, I told you Chapter 6 has a lot of word problems. The whole point in learning how to solve a system of equations is to be able to compare different information. So the base behind, when all of you are asking me all the time, when are we going to use this in real life? When are we going to? This is a huge real life application when you're looking at systems of equations and comparing different data that you might have, trying to find answers to things, trying to decide which plan to use or which company to use for different prices. You're going to find a lot of different word problems that we go over. This particular word problem is talking about comparing two plants. It says you're testing two fertilizers on plants A and B. Plant A is 6 centimeters tall and it's growing 4 centimeters per day. Plant B is 10 centimeters tall and growing 2 centimeters a day. Set up a system that models the height of each plant, so H would be for height, based on D as a function of days, which is your D. This is one of those functions that we started learning about in Chapter 4. So our function is the height of the plant, and the height of the plant is going to be based on how many days you've been recording the information for this plant. So hopefully some of you remember basics of setting up these equations. What you're going to be doing is setting up two linear equations because you have two sets of information. So it's exactly what you learned to do in chapters 4 and 5, but now you're going to be setting up 2 pieces of information instead of 1. So let's go through with pink and look for information about one of them. We know that our function is h of d. So I can start with h of d. And remember, h of d just means y in the end for our equations, if you forgot that from chapter 4. So I'll go ahead and start the first equation. H of d equals something. Now you're going to look through for the first set of information. Let's do plant A. So we're talking about plant A. We know that it's already 6 centimeters tall and it's growing 4 centimeters a day. Remember, these are the kind where this is our starting. So we're just going to have plus 6 to whatever growth we have. And then it's 4 per day, and D is our variable, so 4 a day. This plant, the height of this plant is going to be growing 4 centimeters a day plus the 6 centimeters that it already was in its height. So that is plant A. We can put plant A above it. Now let's look for information about plant B. Plant B also has the same function. Our height is going to be based on our days, and that's going to be equal to, and you go read about plant B, it's already 10 centimeters tall, so we know we're adding 10 to the end, and it's growing 2 centimeters a day, so 2 per day. And there's your 2 equations for this system of equations. Now, if you were the person studying this fertilizer and you were trying to figure out which fertilizer is better for this type of plant that you're comparing here, then what you would do is graph it, look for when they're going to be the same height, and you can start comparing the information about these. Which one is growing maybe faster, which one looks healthier. There's all different types of things you could look at here. This is really just practice at how to set these up, depending on what you would be doing. You don't have to write the graph in, but if you want to, you can. I'm just going to go through the graph so that you can kind of see how it works, but it's up to you for this one if you want to put the graph in below or not. Because this is real-life application and we know that this plant is starting at a height that's in the positive range, we don't have to worry about negatives. So we're just going to look at positives and negatives. When you go to graph, remember this is basically your y. Y equals 4d plus 6. So if I was going to graph the pink equation, I would start on 6 and up 4 over 1. So I start at 6, go up 4 over 1, over 1. And then I'm going to connect to that in a minute, but I'm going to go ahead and plot my points for both right now. If I was going to graph the other equation, I would start at 10 up to right 1. There's 10, up to right 1, up to right 1. I already see the point where they're going to be the same because it just overlapped there. So now I'm going to connect those. Now that I've connected those, I do see that it crosses right here at this point. And now I have all of my possible solutions to compare for plant B and for plant A, and I see which day they are the same height. So my day, remember, day is my independent variable, my x. These are my days based on my dependent variable, my height. My height is based on the number of days. So in 2 days, both plants will be, if we started at 10, 11, 12, 13, 14, so both plants will be 14 centimeters high in 2 days. And we could actually write that. In 2 days, the plants will be 14 centimeters tall. And then what I would do if I was graphing this is I would actually put h of d here for my height, and I would put d down here for my days. I want everyone to write this in even if you didn't copy the graph down, but I do want you to write this part down. Make sure that you understand that when you're graphing, you're going to replace the function name with y. What I mean by that is when you go to graph it using like slope-intercept form or standard form, this right here can just be used as a y if you need to think of it that way. Y equals 2d plus 10. Go ahead and add this to the left side. It's talking about when you come across word problems in this chapter, you're going to set up an equation for each set of given information. For this year, you're only going to be given 2 sets of information all the time. But when you get into Algebra 2, you're going to be given more than 2. You're going to actually be given 3, and you're also going to be given 3 variables a lot. That's part of the reason it's so important to understand everything we go over in algebra, because when you get to Algebra 2, you're just going to be adding to the things you already learned in algebra. You're going to be adding a third of everything as you go through. You're going to notice a lot of things like that. So for this year, most of the time, unless I'm giving you some kind of challenge, you're going to be just given 2 sets of information each time. And then you're going to solve once you set up those equations, and you're going to find the point where they intersect, which is your solution. And then you write your answers in words and label them always. Hit pause, hit play when you're ready to move on. When we are looking at graphing these and finding solutions to them, we're going to find that there are some special cases in systems of equations, just like you found some special cases when you were working with linear equations with just one equation. And you're going to find some similarities that you hopefully will see that tie directly into some of the special cases that you learned about when you were graphing the linear equations also. So let's go ahead and solve this one by graphing so that we can see what happens and compare it. Make yourself a chart, or a T-chart here, or not a T-chart, a coordinate plane. And I'm going to do the same thing, and some of you might really want to think about doing this with highlighters or something. My recommendation would be that I'll actually show you what you can do when you're using pencil, but I'll show you this time. I'll still use my 2 different color pens, but I'll show you what you can do with when you're using a pencil. So the first equation I'm going to graph in pink. It's in slope-intercept form again. We're going to have to do some standard form review, because a lot of these are given in slope-intercept form, but I'll show you in the next example a standard form one just in case you forgot. So you're going to start at 1, but then your slope is down to right 1 because it's a negative. So we started a positive 1 on the y-axis, and then we're counting down to right 1. Remember, you always run right. Down to right 1, down to right 1, down to right 1. My other line, I'm going to go ahead and do in this color. Same thing, slope-intercept form. My slope is -2/1. My y-intercept is -1. Hopefully some of you already noticed something right here, and you already know what's going to happen. Take a look at that and see if you can figure it out before we even graph it. Okay, let's try it. So we're starting at -1. Down to right 1, down to right 1. When you connected your lines, or your points, hopefully you notice that these 2 lines are parallel. And when you compare these lines, they had different y-intercepts, same slope. So some of you might have noticed that even before we did this. Every time you have a set of parallel lines, they are never going to intersect, which we talked about in Chapter 5. If these never intersect, there's never going to be a solution that's true for both of them. This pink line has tons of solutions that are true for the pink. None of them are going to work for this one. The green line or blue line, depending on how it's showing up in your video, is never going to have a solution that's true for the pink line. So these are parallel lines, and every time you come across a set of parallel lines, your answer is always going to be, what do you think? Hopefully you said no solution. So parallel lines, so no solution. And that's going to be true every time you come across a set of parallel lines in this whole chapter. Go ahead and add this to the left side, just that whenever you see parallel lines, you're always going to have no solution. And some of you are so great at recognizing this that in reality, when I see these are both in slope-intercept form and I see the same slope there, I'm not even going to waste my time solving it. Now, if it was a test, you obviously might want to be able to show me graphing it. But in terms of the real world and applying what you know, you immediately know when you see that they have the same slope that you have no solution. So you don't even have to waste your time doing this. Now, you might want to do it because you might be trying to compare something else if you were looking at a real-life study or something like that. Example 5 asks you to solve. They gave you 2 lines. Hopefully most of you noticed that this line right here is in standard form. AX plus BY equals C. Go ahead and copy that down. Remember, when we use standard form, we're looking for intercepts. Intercepts is the t-chart with the 2 different values of 0 for x and then for y. So I'm going to go ahead and start the t-chart over here. This one is easy enough not to show work for. It's all mental math. Sometimes you can use mental math. As you get better and better at the algebra, you want to start using some mental math. But right now, we're still really focusing on showing steps a lot of the time until you feel pretty comfortable with always getting them right. So I'm going to plug in 0 for x to find my y-intercept. Once I plug in 0 for x, this becomes a 0. I get 4y equals 8. I divide both sides by 4, and y should equal 2. So my y-intercept is 2 over 0 up 2. Now I'm going to plug in 0 for y, so this part goes away. I have 2x equals 8 left over, divide both sides by 2, and x is 4. And that's why intercepts is so nice, because you really can use mental math with it. 4 over 4 up 0. I have my 2 intercepts for this equation. Go ahead and hit pause and connect the lines. Hit play when you're ready. So there's our first line graphed. Now we're going to look at the second line. Second line is in slope-intercept form. So we can start at 2, and our slope is down 1, right 2. So we're starting at 2 on the y-intercept, going down 1, right 2, down 1, right 2, down 1, right 2. Hopefully you noticed something that was happening there. When you go to connect these lines, you end up with exactly the same line. So in this case, you have the same line just shown in 2 different forms. So what do you think your solution is going to be here? Hopefully you thought about it and you realized all solutions. They don't just cross at one point, they cross at every single point. No matter what point you choose from this line to plug in, every single time you plug a point from that line in, they're both going to balance out. So your answer to these are all solutions. All real numbers are your solutions. And you can also say infinite. Solutions. So all real numbers or infinite solutions I will take as an answer there. Go ahead and add this to the left. Now, I forgot to show you up in the last example what I was going to tell you you can do for your two lines if you ever want to be able to look at which one is which. Since you don't use pen when you're doing the homework, what you could do is graph the line, and then just after you've graphed it and kind of double check to make sure that your graph is okay, you could always do a highlighter, like highlight the equation and then just go over the line with a highlighter. And that way, if you made a mistake while you were graphing, you could still erase it and fix it. And you could have two different color highlighters. So then let's say, now I should have done this in pink, but that's okay. And then the next one, I graphed it in pencil, I double checked it, everything is good to go, and I highlight the equation, and then I just follow that line I had in pencil. So that's a way that you can use your highlighters if you're trying to show which line is which and still want to use pencil in case you made a mistake. And that is lesson 6-1.